Hey guys, welcome to AI Tech Talks with Carl. Today we're going to be implementing gradient boost regression algorithm from scratch and using it to display a cool GIF of the numerous trees used to fit the model. Note, this tech talk assumes you have seen decision tree regression from scratch, where I show you how to implement regression trees with a running time of big O of V times N times log of N, where V is the number of features and N is the number of samples in the dataset. This allows us to have a fast implementation of gradient boost regression in Python since it uses many of these regression trees. Let's get started. Since gradient boost regression uses multiple regression trees to fit a model, we will be using the previous implementation of DecisionTreeRegressor class. Notice the getBestSplit method and how it minimizes the residual sum of squares by implementing an alternative form of variance for decision nodes. We begin by defining the gradient boosting regressor class to build multiple regression trees that are fit to the residuals of the predictions. We pass in two new parameters into the constructor, including the learning rate for each stage in the boosting algorithm and n estimators, which is just the number of trees used to fit the model. We save each of these passed-in arguments to instance variables of the class. Now we define the fit method and pass in the feature matrix and target values to be able to fit a gradient boosted model to the training set. To be able to use the target label array for later use, we have to save it in an instance variable as self.y. We also have to initialize an empty list to store each regression tree that we plan on fitting to the residuals. Now to fit each of the regression trees in the model, we run a for loop over the number of estimators minus 1. So the reason why we subtract 1 will be more clear when I go through the predict method, but essentially we just use the mean value of all the target labels as the first prediction of the model. This is consistent with most implementations and the way SKLearn does it. Then we instantiate a DecisionTreeRegressor object and fit the model in one line of code. So the first half of this one line uses the regressor class that instantiates an object of that class and pass in parameters to the dunder_init method. The arguments that are passed in are the max depth for the depth of the tree starting at index 0 and the min samples leaf for the minimum number of samples in each leaf. These arguments were originally passed into the constructor of the gradient boosting regressor class for the whole model. Then we use this DecisionTreeRegressor object to call the fit method, which returns self and takes in the feature matrix and target values of the training set. In a gradient boosted model, we have to use the residuals instead of the target values, so we subtract the target values from the predictions to get those residuals. Then we just append this tree to our trees list and continue on with the for loop. When we have fitted each regression tree to each of the previous residuals and added it to the trees list, we return the object and we are done training. Now, the predict method of the class just takes in a feature matrix and starts by creating an empty predictions array to hold the predictions for each sample and each estimator of the model. We can use the np.zeros function to set the rows as the number of observations and the columns as the number of estimators. Note, in this implementation, the number of trees that are fit is the number of estimators minus 1, since the first prediction is just the average of the target labels. Thus, in the next line, we set the predicted value for all observations equal to the mean of the self.y instance variable. Now we can use a for loop to iterate over each tree in the self.trees instance variable and make predictions by calling the predict method of the tree object. The predictions for each observation and each tree will be saved in the correct element of the tree's predictions array. By starting at the iteration i+1, we skip over the first prediction and save all observations in that column. After all the predictions have been computed, the last step is to add the first column of trees predictions to a sum over the learning rate times trees predictions. If we are only predicting the initial predictions, there wouldn't be a second column in the predictions array, so we need a quick if statement to correct it. With this predict method defined, we can call it every time we build a tree, and it will return the predictions of all the previous trees that will fit. So now we can define a gradient boosting regressor object with 20 trees and a max depth of 3, and then fit the model to the training data. We predict using the predict method with a test set and print out the MSE for the model. A simple call to np.mean and np.square is used for the MSE calculation. So let's go ahead and run this, and we see that it runs very fast because of the n times log of n running time for the decision tree regressor. We get a mean squared error of 2,777, which is much better than the MSE for a single regression tree that we trained before. Now all that's left to do is print the tree in a GraphViz tree structure, and we are going to display it in a GIF format on Google Colab. GraphViz is a Python module that SKLearn uses, as well as the XGBoost model, to display decision trees in a graphical format. So if we go to the GraphViz online documentation, we can look in the examples category and see a few examples from the GraphViz creators. If you scroll all the way down, there is a nice example of the code for a binary tree. Here we see that we have to create a graphviz.digraph object to create a directed graph. Then we can call the node method to add a node to the tree, and likewise the edge method to add an edge. In the node method, the first argument is the string label of the node, and the second argument, there are 3 fields of F1, F2, and F3 for the 3 squares in the node rectangle. In each node, we can use the second field, or F1, to enter the information for each node like they did with the capital letters. For the edge method, all we have to do is just specify the string representation that we use for the labels of each of the nodes. Thus, for each edge, there will be a node at the head and tail of the arrow. So we can go back to the code and define a save tree method in the DecisionTreeRegressor class we were using for each tree. We use an index for each node in the tree and start the index at I equals 0. Then we instantiate a digraph object for a directed graph and set the format argument to PNG. To visit every node in the tree, we use a pre-order traversal and either call the node method for a decision node or a leaf node. In the leaf nodes, there will be a values key, and we display the prediction of that leaf. For a decision node, we display the threshold and feature index. Then we define the edges by using the current node label and the node label of the parent. Now we can import image IO to create a GIF of the first 5 decision trees. We can call the save tree method of each tree and save the trees to a PNG file. The rest of the code is just making the resolution consistent between the images in order to save the GIF. After running it, we can see the first 5 regression trees being fit to the residuals of the previous tree. The decision nodes display the threshold used for each decision, and the leaves display the predicted amount to update the previous predictions. So that's it for this Tech Talk, guys. If you liked the video, please support the channel by subscribing and sharing with your friends.